Hello my dear students, in this video I am going to talk about the application of double integrals. Specifically we are going to discuss how to find the area of two-dimensional regions using double integrals. As we all know that the integration of the function f of x from x is equals to a to x is equals to b, and this integration is performed with respect to x. This gives us the area of the region which is under the curve y is equals to f of x and bounded by these two straight lines x is equals to a to x is equals to b. It means that if we have this x-axis, horizontal x-axis, and this one is the y-axis which is meeting x-axis at this point which is origin. If this is y-axis, and suppose that this point, at this point this is the coordinate, for example a comma 0. Let's say this point has the coordinates b comma 0, then the straight line parallel to y-axis which is passing through this point represents the equation x is equals to a. This is a straight line, x is equals to a, and a straight line parallel to y-axis passing through this point represents x is equals to b. Now suppose that y is equals to f of x is this curve. This is y is equals to f of x, then this line would be x is equals to b, and this line is equals to x is equals to a. Then the region, this shaded region, is basically the area which this integral is evaluating using this single integral. Now as we know that in two-dimensional regions, all the two-dimensional regions, those are bounded by four boundaries. Here this region is bounded by four boundaries which are x is equals to a, x is equals to b, y is equals to f of x, and the last one is this boundary which is x-axis. Hence the equation of this line is written as y is equals to 0. So this region is bounded by four boundaries which is x is equals to a, x is equals to b, y is equals to 0, and y is equals to f of x. We can always represent this type of integral where the integral gives us the area of the region under the curve y is equals to f of x from x is equals to a to x is equals to b in terms of double integrals. Let's see how we can do it. We can represent this integral as x is equals to a remains same, x is equals to b remains same, and we'll write this dx here. Now what we are going to do with f of x, we are going to write it as y is equals to 0 to y is equals to f of x, and instead of integrand f of x, now we are writing integrand as 1, and then we'll integrate with respect to y. Now this double integral will give us the same answer as this single integral, because when we integrate this 1 with respect to y and apply these limits of integration from y is equals to 0 to y is equals to f of x, we will get that same integral. Let's see is it true or not. So integrating 1 with respect to y, that would be y, taking the limits of integration which is y is equals to 0 to y is equals to f of x, dx remains same, and the integration with respect to x remains same. Now applying these limits of integration, that would be equals to x is equals to a to x is equals to b, and that would be y is equals to f of x. So this would be f of x minus y is equals to 0, so that would be here, and then dx. So f of x minus 0, that would be f of x. Hence we can see that the final answer after evaluating the integration with respect to y, we get the same answer as the single integral of f of x from x equals to a to x equals to b. It means that as a single integral, this is interpreted as the area of the region under the curve y is equals to f of x from x is equals to a to x is equals to b, right? And in terms of double integrals, we can say that this is the area of the region which is bounded by four boundaries: x is equals to a, x is equals to b, y is equals to 0 to y is equals to f of x. Both gives us the same answer. The only thing which I want to mention here is that whenever we are trying to find the area of two-dimensional regions using double integral, the integrand should be equals to 1, or in other words, we can say that the general form of double integral is written as this is the two-dimensional region D, this is the function f of x comma y, right, in any variable x and y. This is differential of a. dA means since we have two variables x and y, so the change in x is dx and change in y is dy. So whenever we multiply both together, as we are doing it here, that will give us change in the area, right? So this is the general form of double integrals. General form of double integrals. Now if we take this f of x y is equals to 1, then this double integral will give us the area of this region D. That can be anything. We have already studied three types of these double integrals. The first type was when the limits of integration are all constant numbers, means the boundaries are all straight lines. The other format was two of them are constant numbers, other two are functions of x, and the third type was two of them are constant numbers and other two are functions of y. So that will give us the area of that region specifically. But the main thing which I want to mention here is that for the double integrals, if the integrand is equals to 1, then that gives us the area of the region bounded by those lines or those curves in that two-dimensional region. Okay, let's take an example and try to understand it further. For example, I want to find the area of the square in this two-dimensional region. Let's say this is x-axis, let's say this is y-axis. They are meeting each other at origin. Let's say this one is 1, this one is 2, this one is 1, and this one is 2. Now this point and this one is this point, this is this point and this one. If I join them together, this will be a square. If the length of this square is 1, it means that the area of this square should be, according to the elementary geometry, this should be equals to 1 multiplied by 1, which is equals to 1. But how we can do it using double integral? Now we can see here that this region D is bounded by 4 boundaries. What are those boundaries? These boundaries are this straight line, this straight line, this straight line, and this one straight line. Now we need to figure out what are the equations of these straight lines. Since we know that the coordinates of this point are 1, 0. The coordinates of this point are 2, 0. The coordinates of this point is 0, 1, and the coordinates of this point is 0, 2. Hence, this equation is equals to x is equals to 1. This one is x is equals to 2, and this one is equals to y is equals to 1, and this is y is equals to 2. It means that this region is bounded by these four boundaries. Hence, we can write down the integration of 1, as I told you, when you want to find the area of two-dimensional region using double integral, the integrand should be 1. Now we are integrating with respect to y first, so we have to mention the boundaries of y, and then we will integrate with respect to x. Hence, we have to mention the limits of integration afterwards, right? So the limits of y are from y is equals to 1 to y is equals to 2, and then from x is equals to 1 to x is equals to 2. X is equals to 1 to x is equals to 2. So I want to mention here that whenever you write these limits of integration, you always integrate in the x direction from left to right, and in the y direction from bottom to top. You cannot write integration from 2 to 1. You cannot do it from top to bottom. You always do it from bottom to top and then from left to right. So I've written y is equals to 1 to y is equals to 2 and x is equals to 1 to x is equals to 2. Now if you evaluate this, integrating with respect to y first, so that will be y, taking the limits of integration y is equals to 1 to y is equals to 2, integration with respect to x remains same, so that would be x is equals to 1 to x is equals to 2. Okay, solving this, that would be 2 minus 1, so that becomes 1. Integration with respect to x remains same, x is equals to 1 to x is equals to 2, and then solving this, that would be integration with respect to x of 1, that would be x, taking the limits of integration, x is equals to 1 to x is equals to 2, and then solving this, we will get 1, because 2 minus 1 would be equals to 1. You can see here that the answer we obtained using elementary geometry and the answer using this calculus using double integral is same. So the fact is that when you want to apply the double integrals where the integrand is equals to 1, that will always give you the area of two-dimensional region bounded by the four boundaries given here as the limits of integration. So this is very simple. Let's try one more example and see whether it works or not. Okay, let's say I want to find the area of the triangle. Let's see, area of the triangle, let's say this one, where the coordinates of this point are 0, 0, the coordinates of this point are 1, 0, and the coordinates of this point are 1, 1. Right? Now this region is bounded by four lines again. What are those lines? This is straight line parallel to y-axis, this is straight line along the y-axis, this is straight line parallel to x-axis, and this line which is basically the equation y is equals to x, and this line is y is equals to 0. This line is considered as x is equals to 1 because of these coordinates, and this line is equals to x is equals to 0. Hence, using double integral, I can say that I am integrating 1 with respect to y from y is equals to 0 to y is equals to x, means from bottom to top, and then from x is equals to 0 to x is equals to 1, from left to right. with respect to x. Now let's solve it. So that would be from x is equals to 0 to x is equals to 1 remains same. Integration of 1 with respect to y would be y. Taking the limits of integration, y is equals to 0 to y is equals to x. Applying the limits of integration, that would be x minus 0, so that would be x. Integration with respect to x remains same. X is equals to 0 to x is equals to 1. That would be equals to now x, integration of x with respect to x, that would be x square divided by 2. Taking the limits of integration, x is equals to 0 to x is equals to 1. Applying the limits of integration, that would be 1 square divided by 2 minus 0 square divided by 2, and evaluating this, solving this, that would be 1 upon 2. This is our final answer. And using elementary geometry, we know that if these are the coordinates, given coordinates, it means that if I complete this, that would give us the square, right, where the length of the side is 1 unit. It means that the area of this square is 1 into 1, which is 1. Hence, using this diagonal, this divides this square into 2 triangles, with area of each triangle is half of the area of this square, so that should be 1 over 2. So hence elementary geometry also gives us the same answer as we got using double integral. Hence now this is the this is what we have developed here, that whenever we are applying double integrals where the integrand is equals to 1, that gives us the area of 2-dimensional regions, and that 2-dimensional region will always be bounded by 4 boundaries. So we need to figure out those 4 boundaries first, then we can obtain the area of that region very easily. I hope that this video will be very useful for you. I will be back with another video about the area of 2-dimensional regions very soon. So if you have any questions regarding this, you may ask me those questions in the comments box. I will be trying my best to solve your queries. Thank you very much.